Hello everybody, my name is Anya Kantrat. So today I'm here with another video of the subject DSA, that is data structures and applications. So today's topic is about the stack operations. So let us look into the contents. So first let's look into the stack definition. Next is the stack operations. Third is the program on stack operations, and fourth is the application on stacks. So here we can look at it, the information which is given in the pictorial representation, which states about what is exactly a stack and how the working of stack take place. So here in the first diagram of the example one, we can look into a stack with which the push and pop operations is taking place in the top of the stack. And in the second program, we can look at an empty stack, a stack to be pushed from the second stack, and then the stack being popped from the third. So let's look into the next slide. So what is a stack basically? A stack is a linear data structure in which the insertion of a new element and removal of an existing element takes place, the same and the represented as the top of the stack. So let's look into the basic example which is shown here. We look into the elements of the stack. Here the item is being pushed and also the item is being popped from the single stack. Next, what is LIFO? An abbreviation, it is nothing but last in, first out. So basically here, the strategy states that the element that is inserted in the last will come out in the first. So to implement the stack, it is required to maintain the pointer to the top of the stack, which is the last element to be inserted because we can access the elements only on the top of the stack. So what are the basic operations of stack? So in order to make manipulations in stack, there are certain operations which are provided to us. First is the push operation, second is the pop operation, third is the top operation, fourth is empty, fifth is size. So let's look at the push operation. It is used to insert an element into a stack. For example, a stack of elements it contains, you wish to insert an element, it can be pulled from the top. Second is the pop. It is nothing but it is used to remove an element from the stack. So when you wish to not keep a certain number or an element in a stack, you can wish to remove it with the help of the pop operation. Third is the top. So it's nothing but returns the top element of the stack back to its original place. So when you wish to return the top element of a basic stack, you can use the function top. Next is empty. So this function is nothing but operation is nothing but it returns the true if the stack is empty, else it returns false. Next, size operation. It returns the size of the stack. So first let's look into the push operation. So the push operations does nothing but it adds an item to the stack. If the stack is full, then it is said to be an overflow condition. So algorithm for the push is begin, if stack is full, return, end if, else, increment top, stack of top, assign a value, end else, and procedure. So let's look into the basic example where here we have a stack which contains the elements 50, 60, 70, 80, and 90. We wish to push the element 90 to the next. So here, what we do using the push operation, we take the numberings from 0, 1, 2, 3, 4, 5. Hence, the pointer is placed towards the 100th position right after the 90. The top element is 100. So let's look into the next operation. Pop operation. So it removes an element from the stack. So the items are popped in the reverse order in which they are pushed. So basically, if you want to, remove an item from a stack, it's not as same as the push operation. It is different. It's removed from the reverse order. That is the down of the stack, which contains certain elements. So if the stack is empty, then it is said to be underflow condition. So algorithm for the pop operation, let's look into it. Begin if stack is empty, return, end if, else, store the value of the stack, top, decrement the top, then return the value, end else, and end the procedure. So let's look at the example here where you can see a stack of elements 1, 2, 3, and 4. Here the top of the element is 4. You wish to delete the top element. It's nothing but you're popping it. So after popping of the stack, it's done in the reverse order. You get the stack as 1, 2, and 3, which is the resultant stack. Next operation is the top operation. Here it's nothing but it returns the top element of the stack. An algorithm of the top is as follows. Here we can look into the algorithm. It's nothing but begin, return the stack. There is nothing but top and end the procedure. Next. Is empty. Is empty is another operation in stack where it returns true if the stack is empty, else false. So the algorithm for is empty is as follows. Begin, if top is less than 1, return true, else return false, and procedure. So let's look on to a basic program on stack operation. So first is nothing but hashtag include stdio.h. Second, include stdlib.h. Then hash define maximum stack of numbers 3. You can change the size according to your requirement. And int s of max, int top int top, which is equal to -1, and void push int item semicolon int pop void display void main open brackets int choice item is something about in the choice of item you want to explain here. Then while 1 open brackets print f and slash n is nothing but to give the space to the output when you get here. Menu print f if push an element to the stack and overflow the demo. Print f pop an element from the stack and underflow the demo. Print f third one is nothing but the display. Fourth one is nothing but exit. Fifth, again, it's nothing but enter your choice in the output. Scanf, you're scanning the elements produced here, percentile D, and choice, semicolon switch choice. And case 1, here you're explaining printf, enter an element to be pushed. Scanf, scanning the element which to be pushed. And item, push the item, break. If item is equals to pop. In case if item is not equal to -1, print f the element popped is percentile D and item semicolon. We'll use the break operation, then break function. Case 3, display the operation where again you use the break code. Then case 4, exit 1, then default, then print f, please enter a valid choice, then break and close the double brackets. After that, we are using the void push integer item. If top of the stack is equal to maximum size -1, then print f stack overflow and return the value. In case the top value is equal to top plus 1, s of top is equal to item and int pop. So int pop is nothing but int item. Then again, if top is equal to -1, then print f the stack is underflow, return -1. Item is equal to s of top, top is equal to top -1 semicolon. Return the item, then void display, open brackets, integer I. If top is equal to -1, then again stack is empty, return. Then again print f if the stack elements are, the following stack elements are, for the integer I is equal to top. In case I is greater than or equal to 0, I is decremented, that is minus minus. Print f percentile D, n and s of I, double brackets, close. So here you're gonna get the result of the above program. According to you, explaining how many elements to be required and how many elements to be popped, pushed, you're gonna get your desired output. So let's look into the applications of stack. So applications of stack are as follows. In fixed to postfix conversion, redo undo features at many places like editors and Photoshop, and forward and backward features in web browsers used in many algorithms like Tower of Hanoi, tree traversals, stock pan problems, and histogram problems. And backtracking is one of the algorithm designing techniques. So some examples of backtracking are the nitroid problems, n-queen problems, and find your own way through a maze. A game like chess and checkers, or even in the problems we dive into some way, is that it's not efficient to come back to the previous state and go into some another path. So to get back from the current state, we need to store previous state. For that purpose, we need a stack. Then, so it's also used in graph algorithms like topology sorting, strongly connected components, and in memory management, any modern computer uses a stack as the primary management for a running purpose. Each program that is running in the computer system has its own memory locations. So string reversal is also another application of stack. Here, one by one, each character gets inserted into the stack. So the first character of the string is on the bottom of the stack, and the last element of the string is on the top of the stack. After performing the pop operations on the stack, we get a string in the reverse order. Stack also helps in implementing function call in computers. The last called function is always the completed first, and stacks are always used to implement the undo or redo operation in text editor. So thank you for watching my video. If you really like this video, please give it a thumbs up and like, share, and comment, and stay tuned for the upcoming videos. Thank you so much.